Hello world, Noah here, and welcome to the second lecture in the CS University series of lectures. In this lecture, we're going to talk about variables, which is our first programming concept. So the first question, what is a variable? Well, simply put, a variable is a symbol that represents a value, and that may sound a little bit abstract and a little bit confusing, but let's try to motivate that a little bit because I think it's actually, maybe a little bit easier or a little bit simpler than you might think. And to do this, let's think about where you might have heard of variables elsewhere. Chances are, if you've taken a math class, you've probably, talked about variables there. So perhaps you've seen, something like y equals 2x, right? So x and y here are variables. Generally we say they're numbers. We could change the value of x and that would change the value of y, or we could change the value of y and that would change the value of x, in the same way. And so essentially, here are some variables. And we could imagine, for example, let's say if we made x equal to 1, well, that means that y would be equal to 2, right? Or if we made x equal to 2, then y would be equal to 4. And this is, really simple stuff, but it basically illustrates the idea that we want to get at. So these variables, x and y, you can think of them as symbols, right? I mean, they're just letters, but we could call them symbols, and they represent values. So in this case right here, they represent the numbers 1 and 2 for x and y respectively, and for here, they represent the numbers 2 and 4 for x and y respectively again. And so basically the idea is that these symbols, they represent numbers and they can change. X was 1 over here, and then I made x equal to 2 over there, and then of course y changed in response to x, but that's sort of beside the point. The point though is again that they basically represent numbers and you can change them. And you could also even think about constants that you've seen in math. So for example, pi, which is equal to 3.14159, blah, 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 blah. And the number e, which is equal to 2.71, blah, 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 blah. And, there are tons of other ones that you've seen in a math or a physics or a chemistry class or wherever else. But again, this is sort of the same idea. These letters, pi and e, basically they're symbols again, and they represent values. Now, these are constants, which means that the value doesn't change, but it still illustrates, again, that fundamental idea of a symbol representing a value. And so when you want to do a calculation that uses pi, for example, you want to calculate the circumference of a circle or the area of a circle or whatever, instead of having to write 3.14 or whatever, you can just write the symbol pi, and it's, understood what that means. It represents, this infinitely long number. And so this essential idea is the exact same in programming. In programming, again, a variable is a symbol that represents a value. But the thing about programming is that our variables can be a lot more complicated. Because in math, we generally deal with numbers, right? So, y equals 2x, and we make x and y be different numbers, or pi and e, which again are numbers. But in programming, we deal with all kinds of different information, all kinds of different data. And so our variables could be numbers, but they could also be words. They could be complex types, which we'll get into in the future. They could be lists of things. They could be, sets of things, and so on and so forth. So essentially, the fundamental concept of this is the same, but variables are a bit more complicated in programming, or they can represent, more data, and we can do more things with them in programming. And so we could sort of imagine, we're talking about, sort of these symbols that represent values, and where could this come up in programming? Well, a good way to think about it is if your code has some data associated with it, then chances are that data would be stored in a variable somewhere. And so you could imagine some different things that you've interacted with that are programmed. So how about a video game, for example? So you could sort of think of all of the different pieces of data, that need to be, available to a video game in order for it to work correctly. So something like, for example, the score, something like the number of lives that a player has, and so on and so forth. You could think about, the level that the player's on, the textures, the images, the sounds. All of this data basically has to be represented, somewhere for the code to use, and so they're stored in variables. You could also think of, an app that you use, let's say, a web browser. And what kind of data does a web browser have to have? Well, it would have something like the URL of the current page that you're on, your bookmarks, your favorites, any cookies that you may have saved from different websites, any passwords you may have saved, and so on and so forth. When you think of anything that's basically, programmed, there's a ton of data associated with it generally, and you can sort of think of all of that data, and that data has to be represented in the code, right? So that you can access it and use it and modify it, and so it would be stored in a variable. So that's sort of the motivation for a variable. So let's look at, sort of how they work in code and how they work in Python. So first, the parts of a variable. There are 3 pieces that are needed to create a variable: the type of the variable, the name, and the value. So the last 2 should be fairly self-explanatory. If we look, for example, at what we just saw, we could have a variable called pi, right? The name of the variable would be pi, and then the value would be, 3.14, blah, 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 blah. And again, we have e, which is 2.71, blah, blah, blah. So right here, this would be the name of the variable, and this would be the value. And these 2 ideas are the same as we saw in math, and they should be pretty self-explanatory. But then the interesting one that comes with the programming side is the type of the variable, because we're not just dealing with numbers in code. We're dealing first with different types of numbers, but then also with different, types of data altogether. And so you have to basically keep in mind what type of data, what type is my variable, what type of data is my variable storing. And so let's look at some of the very basic variable types in Python. And, this is, of course, standard across all different languages. But there are 4 right here, 4 very basic ones that you need to know. And, of course, there are an infinite number of them because you can create your own types. And there are other important types that we will discuss in future videos. But just to look at these 4. The first one is int. It stands for integer, or it's short for integer. And an integer is the same in code as it is in math. It's a whole number. So something like 1, 10, -5, etc. An integer is a whole number. And I think that's pretty straightforward. A float stands for a floating point number. And that's not really important. You don't need to worry about, the name. Why is it floating point? What does that mean? The idea is that a float is a number with a decimal place in it. So for example, 10.5, 2.7, -3.6, or even something like 10.0. I mean, you could say it's 10, it's an integer, but it does have this decimal place right here, this 0.0, and so therefore it would be a floating point number. So those are 2 different types of numbers: whole numbers and floating point numbers, aka decimal place numbers. But then we can look at some other types of variables. So str stands for string. Whoops. str stands for string, right? And so a string is basically, just some text, right? So for example, it would be something like, the word hello, or something like my name. And the important part about a string is that it needs to be contained within quotation marks. You can either use double quotes, or you can use single quotes in Python. It doesn't make a difference. I personally prefer to use single quotes in my code, but if you prefer to use double quotes, you're more than welcome to do that. The important part basically is that a string is just a series of characters, so it could be, letters, numbers, or symbols. It could be something like, maybe your password is pass W1 exclamation point. I don't know. But the idea is that you have letters, numbers, and symbols, whatever you want, as long as it's contained within these quotation marks. It's very important. So that's a string. Again, sequence of characters. And the last one that I have here is a bool, which is a Boolean. And a Boolean is very simply a value that is either true or false. And in Python, we use capital T for true and capital F for false. But again, a Boolean is either true or false. And you may think, what's the point of that? What's the point of a variable type that's either true or false and it can't be anything else? This will come up later when we start talking about conditionals. Basically, when you make a comparison of some sort, you'll get a Boolean. Is this variable bigger than this variable? Is it equal to this variable? Whatever. When you're asking a true or false question, the result will be true or false, of course, and so it'll be a Boolean. And so we'll come back to that more later, but just to sort of give a quick introduction, a Boolean is a true or false value. Okay, so let's try and actually declare some variables. I have three things right here. Let's declare a variable to represent name, age, and bank account balance. Of course, that will be something sort of arbitrary. And so we're actually going to declare these variables in the Python syntax because it is incredibly simple. And so before we do, what we said before was that there are three basic parts. There's the type, the name, and the value. So for each of these, we want to remember type, name, value. We want to figure out each one. Now in Python, you don't actually need to know the type of the variable because Python is smart enough to figure out what type your variable is based upon the value that you give it. But when we're trying to, sort of create these variables, we should be thinking about what types they'll be so that we can pick the correct type. So for example, I want to create a variable to represent my name. So I need to think about what type this variable should be, what the name should be, what should I call the variable, and what value would it have. Well, first we can think about the type. So a name is going to have some letters in it, right? We know it's not going to be a number, and okay, it's not a true or false value. And so we think, okay, this has to be a string, right? Because a string is a sequence of characters, a sequence of letters, numbers, and symbols contained in quotation marks. And so we know that name has to be a string. And so I'll write that as a note, but we don't actually write in our code, that it's a string because Python can figure that out. Now, the name of our variable should explain what the variable actually represents. So if I called this something like X or A, that wouldn't be a very good idea because it's not descriptive. If you look at a variable called X, you say, well, what does X represent? I don't know. We want to give it a name, that sort of explains what it is. And oftentimes that's going to be exactly what you think it's going to be. So in this case, the best name for this variable is name, right? Because it represents my name. And so if the variable is called name, I see that and I say, oh, the variable is called name, it must represent a name. Very, very simple. And the value is, of course, going to be my name. And we said since it's a string, it's, a sequence of characters in quotation marks. And so all we do is first we write an equals sign, and then I'm going to write my name in quotation marks. And I know that I said that I prefer single quotes. I wrote double quotes right there. So you could write Noah in double quotes. Let's do that again. Or you could write it in single quotes, but you need to make sure you have the quotation marks. If you don't have the quotation marks and you try to run this as code, it'll give you an error message. But essentially, what have we done? We've created a variable called name, and we've assigned it. This is the assignment operator. It assigns a value. We've assigned it, we've assigned it the value of Noah in quotation marks. And so Python is able to figure out, oh, this is, a sequence of characters inside of quotation marks, therefore it's a string. And so it's able to figure out that name is a string, and we didn't need to tell Python that. But again, we want to keep in the back of our minds what type of variable we're dealing with, because that will denote what we can and can't do with that variable when we actually go to use it. So let's take a look at the next example. We can go a little bit faster now. The next example will be age. So for this, what's it going to be? Okay, well, it's a number, right? And let's go ahead and say that it's a whole number. We're not going to say, oh, I'm, 2.5 or whatever. We're not going to keep track of that. We're just going to say what's the age, as a whole number, which is in Python an int or an integer. And again, we're just keeping that in mind. We don't need to actually write that it's an int because Python's smart enough to figure that out, but we just want to remember that. So what should we name this variable? Again, it's usually the obvious answer. I would name this variable age, because when you see a variable called age, you know that it represents an age, and that's pretty straightforward right there. And we're going to use the equal sign. We're going to say this variable called age is equal to, and then, I'm going to, put my age. So I'm 20 years old. So I'm going to say 20. I'm not going to use quotation marks. If I used quotation marks, right, then it would be a string. But we said that we want it to be an int, which is a number. And that's, again, why you want to keep in mind the type of the variable, to make sure that you declare it correctly. If I wrote age equals 20 and I put quotation marks, age would be a string. And as we'll see in the future, that would be not a good idea. We don't want to do that. So, okay, so we are just going to write it like that. So again, we're creating a variable called age, and it's equal to the number 20. And the last one, we want to keep track of, our bank account balance. Maybe this is, a banking app or a banking website or whatever it is. And so again, type name value. Well, the balance is going to be a number, right? But it's in dollars and cents, so it's going to have a decimal point in it. So we want to use a decimal point number, which is a float in Python. So it's a float. What do we want to name the variable? I'm just going to call it balance. You could call it bank account balance if you want. And if you did that, you would have to use underscores, so bank account balance. You wouldn't use spaces. You can't use spaces in Python for a variable name. Or in any language, really, you can't use spaces. So you'd use underscores, but that's kind of a long name, and I think balance gives, plenty of context for what it is. And so balance is equal to whatever. And let's say it's $100.29. I obviously made that up, but just imagine, for someone's bank account, their balance is $100.29. So balance is equal to 100.29. And again, I did not use quotation marks because it's a float, it's a number. And if I use quotation marks, then it would be a string, which is, a sequence of characters. And again, it may not be clear why that's important, but as we'll see pretty soon, it is important, and so you should keep that in mind. So there we've gone ahead and declared, 3 variables, name, age, and balance. 3 different variables, 3 different types. I think you sort of get the idea, but just in general, the formula is name equals value, where name is the name of the variable, value is the value, and then the type, you don't actually write the type, but the type can be inferred by the value. You say, You say, here's, something written in quotation marks right here. It must be a string. Oh, here's a whole number. It's an integer. Oh, here's a decimal number. It's a float. You get the idea. Python's smart enough to figure that out. But this right here is basically the formula, and it's very simple. There is also something in Python called multiple assignment. It's really just for you to make things a little bit easier. But imagine we had a variable a equals 1, and we had a variable b equals 2. We're assigning, a equals 1, and then we're saying b equals 2. Well, in Python, you can actually do this on one line. You could say something like a comma b equals 1 comma 2. And the way this works is a will be equal to 1, and b will be equal to 2. And I think that's pretty straightforward as to what's going on there. basically it allows you to have multiple assignments in one single line. And you could do ABC equals 1, 2, 3, as many things as you want, so on and so forth. There's nothing wrong with having each assignment on its own line, but if you have a bunch of them in a row, perhaps you'll find this to be useful. So I figured I'd just take a second to mention it. But that's basically all. And then the other thing that I'll show you is the type function. And so basically, this is a built-in function, and we'll learn all about that later, but it's this thing, this feature of Python where you can give it a value and it will tell you what type that value is. So, imagine you have some sort of a variable that you get from somewhere and you aren't sure, what this variable is. Well, you can just go ahead and use the type function and it'll tell you. And so let's just answer a couple of these questions. There's 4 questions right here. Determine the result. Determine the type of each thing. So just to be clear, the syntax, it goes like type, and then whatever is inside of the parentheses is the thing that we're looking at. So in this first example, we're looking at this number 10, and we're saying, what type is this number 10? We can say, okay, well, it's a number, and it's a whole number, and so therefore it must be an int, or an integer. And then here we're saying, okay, what's the type of 12.2? It's a number with a decimal place in it, and so therefore it is a float, or floating point number. Here we say we have this word hello in quotation marks, and we say, oh, there's a sequence of characters in quotation marks, and so it must be a string. And finally, in this example, we say, what's the type of true? Okay, we know that's a bool or a boolean, because again, we said a boolean is either a true or false value. And so that's basically the idea with the type function. It's very simple, but if you stick a value or a variable in there, it'll basically tell you its type. In the corresponding lab, we'll actually write some variables and sort of get a better idea as to, why exactly they're useful and, how exactly you use them. And then we'll also look at some more confusing type puzzles. So they'll basically look like this last slide that we just looked at, but they'll be a little bit trickier, and you'll have to make sure that you really understand how all of these types work in order to solve them. So that's all for this one. I'll see you guys in the next one.